There is much development occurring in GNSS in all of these systems. A number of these systems are interoperable. In conjunction with RAIM receivers, this level of redundancy in satellite constellations provides the possibility of integrity monitoring and accuracy measure improvement at the user's receiver. The future here is unclear. As I said earlier, further studies will be required in relation to second generation DGNSS. The GLA's DGNSS service will continue in the short to medium term. The current project will provide a system with a life of approximately 10 years. Thank you very much.
And very interesting paper that since that the marine GPS which have been installed more than 10 years, that I think that the maritime authorities will not the same problem, that the existing system will have a relatively low reliability due to aged the component. So far as I know that the average life for electronic computer, the element, the average would be 8 years. So that in this case, that we should do something to raise the reliability, to make the system running. And this is a common problem here in front of us all. Thank you very much for the paper. Now the next speaker is Mr. Mahesh Alimchandani. Mr. Mahesh Alimchandani is the Network Planning Manager and Nautical Advisor in the Navigation Safety Section of the Australian Maritime Safety Authority. As Master Mariner and has served on ocean-going cargo vessels for more than 14 years. He has a master's degree in business administration from the University of Canberra. He is Associate Fellow of the Royal Institute of Navigation of the UK and a member of the Nautical Institute. From the year 2006 to 2008, he worked as ILA as a technical coordination manager and was responsible for coordinating the work of various committees and was also the secretary of all ILA technical committee.
Thank you for that introduction, Mr. Chairman. Good afternoon, everyone. My presentation today will start by outlining why AMSA has set about implementing an underkeel clearance or UKCM system in the Torres Strait. I will briefly describe the operational model, that is, how AMSA sees the system working in practice. I'll then outline the functions that are required of the system, and I'll finish with some of the main tasks that AMSA will undertake in implementing the system. Dr. Terry O'Brien's presentation on Tuesday described a web-based UKC tool to aid decision-making. This presentation offers a different perspective, a safety regulator's perspective of UKC management. But first, an introduction to the Torres Strait. The Torres Strait lies between the northernmost point of the Australian continent and the island of New Guinea to the north. It is a major shipping lane for Australia and Papua New Guinea. The Varzin and Gannet passages in the west, and the Prince of Wales Channel in the center, on there, have limiting depths. Deep draft vessels need a rise of tide to transit through the region. The Torres Strait has fast-flowing tidal streams. Up to 8 knots have been experienced in the Prince of Wales Channel. Here, large commercial ships are confined to a few well-defined routes that are hazardous to navigation, owing to their narrowness, only 800 meters wide in one location, limiting depths, and a complex tidal regime. Over the years, AMSA has put in place a number of measures to improve the safety of navigation and protect the environment. Now, in order to validate the existing safety margin beneath ship's keels, AMSA has commenced implementing a UKCM system. For those that picked up on the fact that the vessels were navigating on the port side of the channel rather than starboard, I can assure you that the rules of the road are not different in Australia. The animation was the work of a non-mariner. It also goes to prove that mariners are required everywhere. So, why are we doing this? Why a UKCM system in the Torres Strait? Firstly, there is a general expectation from industry, from both ship operators and coastal pilots, that ships can transit the region with deeper drafts on some days of the month. And I stress that on some days, there is more water, there is more height of tide for ships to be able to get through with deeper drafts. There has been a request by vessel operators over years for AMSA to re-examine the draft regime. And the current draft regime is a limitation, a maximum permissible draft of 12.2 meters, that's 40 feet, with an associated minimum UKC of 1 meter. That's the rules as of today. Since 2006, there has been 100% uptake of pilotage, and therefore AMSA can ensure that coastal pilots are trained and equipped to use this aid to navigation. In some ways, UKCM systems can be seen as a current generation aid to navigation. While they have been around for some time, their use has become more widespread in the last decade. And therefore, with the UKCM system, AMSA will be able to validate the existing safety margin. Subsequently, then evaluate the appropriateness of the maximum draft regime that's in place, and move from a static to a more dynamic UKC regime. In 2009, AMSA released an open tender, and Melbourne-based OMC International Proprietary Limited, an IOLA industrial member, was selected as the preferred tenderer. 2 key documents formed part of the tender package. The first is the operational model. The second is the business requirements. What is it that we expect the system to do? I'll cover both of these in the coming slides. Firstly, to the operational model. AMSA's UKCM system will operate in 3 stages, which will follow one another. And these are the voyage planning stage, transit planning, and UKCM assisted. Let's see what these are. In the voyage planning stage, ship operators